Welcome to my presentation on connecting the Australian AuScope Geochemistry network into the global One Geochemistry initiative. Before I start, I would like to acknowledge and celebrate the first Australians on whose traditional lands we meet, and we pay our respects to the elders past and present. This is the abstract to my talk. I've just included it because these usually get passed around with the presentations. I'm not going to talk any further on the AuScope Geochemistry network because there are quite a few other presentations on what AuScope Geochemistry network is about. What I want to do in this presentation is say, well, if this is what the AuScope Geochemistry network is, how does it connect to new initiatives that are going on in the international geochemical scene? Today, the acquisition and analysis of geochemical data is globally pervasive in the earth, environmental and planetary sciences, and in fact has been since the mid-19th century. Geochemistry is fundamental to understanding past, present and future processes in natural systems, including the evolution of the Earth system, solar system and universe, societally relevant topics, environment, resources, minerals, groundwater, energy, geohealth, ocean and agriculture, and above all, the United Nations Development Goals. Properly curated, any existing geochemical data set could be repurposed in support of most new scientific and societal challenges. The UN Sustainability Goals are very important and are part and mentioned in the AuScope Strategic Plan. And geochemistry is relevant to at least 6 of these, if not all. And what that also means is that geochemical data has to be integratable with other global initiatives that are happening in biodiversity data, environment data, and all sorts of other types of data. And so what we're aiming for in our vision is fair, findable, accessible, interoperable, and reusable. We want a distributed framework where geochemical data are globally accessible using web services, a coordinated data federation that ensures complementarity of data resources to minimize duplication and maximize comprehensiveness, a sustainable data infrastructure that guarantees that we have persistent, machine-readable access to the global wealth of fair geochemical data. And I emphasize, if it is not machine-readable, it is not fair. And that was in the original definition of the principles in 2016. In reality, the geochemical data landscape is fragmented. Geochemical data lack common metadata data schemas, formats, vocabularies, which makes it hard to find, access, and reuse them. Geochemical databases tend to be built in thematic, institutional, national, or programmatic silos. Geochemical databases are uncoordinated, and often data can be duplicated within them, making global merging of datasets complex, and dare I say, it leads to competition as to who's got the best and spiffiest database. We really need these silos to come together and integrate seamlessly to harness the wealth of geochemical data in support of basic and applied science. And we know this has been done. It's been done in seismology, in biodiversity, in crystallography, and in climate. So what we're proposing is nothing new. It's just that it's geochemistry, and it's proving difficult. We know that we have to be international. Modern research papers, as the synthesis from Nature shows, are increasingly international collaborations with multinational authors. But what this means for geochemistry is when they get together, they then start compiling data from each other's sources into another database. We need to try and develop a system that will not require this to happen. And so we're at the starting blocks, and AGN is now working with Germany, the Diggers and the GeoRock project, the European Plate Observing System Multiscale Laboratories Project, and the major United States EarthChem database. So, sadly, the current state is this: multiple human-readable systems, some with metadata. Some advertise they're fair, but in fact they're only fair within that system. You cannot use or reuse or interoperate the data from that system with another one in a machine actionable environment. The developing state, as I said, is these four are starting to get together and trying to break down this human readable barrier around the edge. And ultimately where we want as a future state is where they all come together. They all have metadata, and they are machine actionable systems, each compliant with globally agreed community standards and all fully ready for AI and machine learning. With better standards, we can move from maps. I think this is an important point, that image or map has been the main means of communication of geoscientific data since William Smith's map in 1815, and we're now progressing to building isotope maps. But if we can engage with the semantic web and knowledge graph, we can now visualize millions of individual words and objects, and not focus on creating visualization or interpretations of millions of words. This is the new science. But to get there, we have to start looking closely. Most geochemical systems are down here. They use technologies such as this XML, relational databases, that only enable recovery and discovery by humans. They are not machine readable. The lack of standardized vocabularies and definition of minimum core variables limits semantic reasoning and development of knowledge graphs. Many systems are designed for visualization within their systems, not global sharing of data at the object level to enable greater uptake of AI and machine learning. We need geochemistry to start getting up here in ontologies and maximization of data. And we're already there though, we're starting. And this plethora of papers that I've got here are showing where groups are getting together and drawing your attention to this one in AR. Not only are they getting internationally, Australians are there. Here's Dave Phillips, Erin Matchin and Paolo. And so we're starting to say, well, if we've got this standard in Australia, how does it fit globally? And so we're starting to get this one geochemistry off the ground. And we've got quite a few conference presentations coming up. And we've got proposals in for Goldschmidt and also EGU. And I'd like to emphasise that all promote the need for global community agreement on minimum common variables for each data type and analytical technique. None promote a specific database. And this workshop proposal for Goldschmidt in particular draws in the publishers. Because if we can get the publishers to agree on a minimum set of data that are required to validate and certify the data, then we're starting to get somewhere. And so I'd just like to finish by saying, One Geochemistry is not a single online database, a single system, or a system of systems. It seeks to address the urgent need to define the building blocks of a global framework, including minimum core variables, vocabularies, and machine readability of data, particularly for validation of data in publications. It is focused on fair data, where data is also fully AI ready and usable for modern machine AI ML techniques. But above all, it still has to allow for that deeper domain specialization and innovation, the development of new techniques, and constant improvement and evolution of existing techniques. It's got to be a dynamic system that allows for scientific progress and changes as we go through time. But above all, AGN needs to be in it, and it already is in the thick of One Geochemistry. If you'd like to join us, here is a list of the current participants, and feel free to contact any of us and participate, particularly if you have an existing geochemical database system. Thank you.